Okay, now.
Hello, everyone. Thank you for joining us today. I'm John Snell, Brain Program Technical Director at the Focused Ultrasound Foundation. I'd like to welcome all of you, those online and here in person, to today's presentation on blockchain, a healthcare-focused introduction. A quick note for those of you on the webinar: if you'd like to ask Rick Hamilton a question, please submit it via the chat function at any time during the presentation. We will collect these questions until the Q&A period begins at the end of the presentation. We will get to as many questions as we can during the time we have. And now I'd like to introduce Rick Hamilton, a distinguished engineer with Optum. Rick Hamilton works broadly across strategic imperatives including machine learning, genomics, blockchain, Internet of Things, and cybersecurity to help people live healthier lives and make healthcare work better. With 874 issued U.S. patents, he was formerly the most prolific inventor in IBM history and has completed engagements involving cloud, artificial intelligence, Internet of Things, and invention strategy in 30 countries. Today, he will give a presentation entitled Blockchain, a Healthcare-Focused Introduction. Rick Hamilton, the floor is yours.
Great. Well, thank you very much. Thanks to everybody in the room for being here and for those of you listening live. This is it's always great to be back at the Focused Ultrasound Foundation. I feel like it's home here. When I started thinking about how we wanted to give this talk, it occurred to me that when we look at blockchain content, there's really two broad categories of content that are out there. One are these utopian manifestos praising the virtues of cryptocurrency, urging you to sell your IRA and invest everything in Bitcoin. And I knew that's not what we wanted to cover. Another class of content we find on blockchain is around these dense mathematical descriptions that force you off to the library shelves to pull out your college textbooks to understand. And I knew we didn't want to do that either. We want to find a different road. So today we want to try to give you a visceral feel for how blockchain works, but to do it in a non-mathematical, or mostly non-mathematical way. We also want to talk a little bit about the use cases, the ecosystems and platforms that are out there, and mostly importantly is to give you a fundamental feeling for when blockchain might be a good match for your use case or your business process and where it's not a good match. So where do we begin? I'll say that we're going to talk a little bit about the technology today, but this is not a technology deep dive. I would also tell you that Bitcoin is not central to healthcare use cases, but I'll talk just a little bit about that because if you understand the origins of blockchain through Bitcoin, it helps you understand it more holistically. Finally, before we get started, I want to credit my Optum colleagues, particularly Mike Jacobs, for helping me pull together content and really being able to articulate healthcare possibilities. So let's start with the simple basics. What is a blockchain? Well, it's really pretty easy. A blockchain is a shared, permanent, encrypted data set created by a network of computers according to a set of software rules. That's all there is. It's a special kind of distributed database. The interesting thing, though, is that this distributed database is spread across a network of computers that have no reason to trust each other. But through the underlying protocols, you can create currencies. You can create a platform for mission-critical transactions. As we'll see later, there's a lot of different blockchains in existence. Their common trait is that they're a continually growing list of records called blocks, and they're all secured using cryptography. But these are really simplistic definitions. If that's all there is, if they're just lists of records, why is there so much hype around blockchain? Well, I presume you're familiar with the Gartner hype cycle. We have here the Gartner hype cycle from the summer of 2016, and it shows blockchain up at the peak of inflated expectations. That means there's a lot of talk, there's a lot of buzz, there's a lot of hype around blockchain, but corporations are not really seeing the full value yet. I would argue that it continues to be the source of great buzz, even a year and a half, almost 2 years later. But we're also now beginning to see increasing excitement around use of blockchain in different domains.
The conference has been muted.
Just last summer, healthcare blockchain started creeping up the hype cycle. So to set the stage for today, much of what we're going to talk about is really generic to all blockchains. But as we stated, we're going to be really zooming in on the healthcare focus when we get to use cases about 3/4 of the way through. But let's begin by diving into some of the history behind blockchain, because that's really quite fascinating. So if you go back to the year 2008, there was a paper published called Bitcoin, a peer-to-peer electronic cash system. And this was published by someone or some group named Satoshi Nakamoto. Now, the interesting thing here is Nobody really knows who Nakamoto is or was, if it's one person or a group. But whoever Nakamoto was, he described a protocol for blockchain. And he described this protocol, and he also registered the Bitcoin domain address, as well as creating the early versions of the Bitcoin software. In 2010, Nakamoto drifted off the face of the earth, off the map. He's faded into obscurity, whoever he is, but I would note that addresses associated with Nakamoto contain about 1 million Bitcoins, which at one point last year at their peak made him one of the 50, if he was one person, made him one of the 50 wealthiest people on earth, at least on paper or on a ledger. Even today, he'd be worth around $7 billion. As we said, Bitcoin is based on this new concept called blockchain. And let's revisit this for a minute. Blockchain is an append-only database. It's distributed on different servers around the world, so there's no one server, no one person running this. So let's ask the obvious question, so what? What does that matter? Well, it was interesting because it was the first mechanism, the first digital currency to solve the double spending problem, and the double without a trusted authority. Now, the double spending problem was a common problem with electronic cash. It meant if I had an electronic token, what prevents me from spending it with you and you and you and you? The only way to prevent this in the past was some authority figure, often a bank. It's what stops you from going to an ATM, pulling money out, driving to the next ATM, pulling the same money out, driving to the next ATM, et cetera, et cetera. But blockchain, as manifested in Bitcoin, was able to solve this double spending problem without use of a central authority. Interestingly, also, blockchain provides a way for us to actually own a digital asset. It creates digital scarcity. Now, think about what a digital asset is. It's ones and zeros. This can be an MP3. It can be a computer program. It can be an electronic health record. And for all time, since we've had digital assets, if you can see my ones and zeros, then you can make a copy of them. And we've tried to prevent this with encryption schemes and to keep people from copying our ones and zeros. But the fact is, digital piracy has always been a problem. But now, blockchain allows us to solve this problem because it doesn't just record the ones and zeros. Rather, it also has an open ledger that records the owner of those ones and zeros. So let's say it's something a little bit more powerful or a little bit more impactful than an MP3. Let's suppose it's my house key in electronic form. If Rachel sees the ones and zeros that make up my digital house key, that's okay if it's on the blockchain. If it's not on the blockchain, she could probably get in my house. But if it's on the blockchain, then in fact, the ownership is recorded to me. And even if she has the ones and zeros, she cannot enter. I would also urge you to look at the date that this paper came out, 2008, and think back to what was happening then. This was the era of Bear Stearns and Lehman Brothers and the Great Recession getting underway. So we had this sudden moment in time where digital libertarians said this is a tool for us to move away from the centralized banking system. And it was only with the course of time that people began realizing that blockchain could be used for more than simply cryptocurrency. But let's start with that first use case, and that was for cryptocurrency. So let's suppose in a hypothetical world, there's somebody with some very dashing hair named Rick, and he owes Neil $100. So in most circumstances, Rick would swing by and drop a check off with Neil, but it just so happens Neil is out vacationing in the Dolomites right now, having wine and cheese, and so this has to be done electronically. The good news is there's long been a means of sending money electronically, and this involved an intermediary. Dating back to the 1970s, we created the ACHs, the automated clearinghouses, and these perform a valuable function. However, the problem with the ACHs is that it takes some time for this process to clear. The ACH has to go in and make sure that my ledger at my bank is sufficiently debited and that Neil's ledger is sufficiently credited. So despite the fact that it's a valuable function, it's also the source of delay and overhead. So a question can be asked, what if there was a single ledger to simplify reconciliation? The answer is the transaction would be conducted much more efficiently than it could be today. It collapses the reconciliation step, it speeds the process and removes overhead, and this is a fundamental and important blockchain advantage. Now, when we take this out to the next level, we can begin asking, what if this ledger was tamper-proof, resilient to failures, and secure transactions were validated through consensus? In blockchain, there is no single point of failure because everybody has their own copy of the data. It's append only, meaning that you can't go back and change things that have already happened. The other forms of the original public blockchain, again, were anonymous users, that everybody could have read-write access, and there's many powerful concepts here, but you're also beginning to realize something. Some of these things I'm talking about aren't well suited for enterprise use. If you're working in healthcare, do you want anonymous participation? Do you want full read and write access to your medical records? I think not. So as organizations began asking these questions, a major new development in blockchain happened. And this was a concept called permission or private blockchain. This was driven primarily or originally by the financial industry. In this kind of blockchain, every participant is well defined and their accesses are based on role. Think of it as a monitored ecosystem as opposed to the open ecosystem. Permission blockchain isn't looking to overthrow the international banking order. Rather, it's taking some of the best characteristics of blockchain, permanence, data synchronization, and process automation, and now making it ready for the corporate world and the enterprise world. Most blockchain research and development happening today are on permissioned blockchains, and I would also say for healthcare use cases, permission blockchains are really what we're interested in. So with that, let me take you to the first two takeaways. The first takeaway I want you to remember after today is that there are two major flavors of blockchain. One is the public kind, as manifested in Bitcoin. The second is the permissioned kind or private kind, and this is where you invite participants to be on your blockchain. The second takeaway is something I've only implied so far, but we'll spell it out explicitly now. When is blockchain useful? It is most useful when loosely coupled organizations want to confidently share and audit information and audit mutually beneficial processes. We'll come back to this statement later in the hour, but for now, let's start easing into a few more specifics behind blockchain's operation. So there are four things that make blockchain unique as we start peeling back the onion. Let's talk about each of these. The first is that it's distributed. We mentioned this a minute ago. What's important about that? We create a synchronized distributed copy and we give it to everybody participating on the blockchain. So if you want to read the data, you read it from your own copy. Why is this important? It's important because it means if Roger's copy of the blockchain goes down, it's no problem because everybody else has one as well. So there's no single source of failure. Secondly, blockchain is an append-only structure. And in a typical database, you can edit records. So maybe I have a variable I call account balance, and one day it's set to 0, and then it's up to 50, then it's to 0, and then the next day the account is deleted. What you see when you look in that traditional database is going to be dependent on when you look at it. You're going to see 0 or 50 or 0 or nothing. But in a blockchain configuration, the record is kept for all time. So you can see that the account went from 0 to 50 to 0 and then was just deleted. So this creates an immutable, unchangeable audit trail. A third thing increasingly important about blockchain operations are what are called smart contracts. Broadly, a smart contract is business logic that checks a condition and takes an action. We'll talk more about these in a few minutes, but think of these as codifying legally binding agreements. Performance can be measured against contracts, and then payment or other actions taken on the outcome. The fourth element of a blockchain that I want to have you thinking about here are incentives. And incentives are intangible. So the reason why you would participate in a blockchain. Now, if you're talking about cryptocurrency, the reason is obvious. I want to mine Bitcoin and make myself a fortune, right? But for things outside cryptocurrency, the incentives are far more subtle. Maybe the incentive for an organization is to have very valid data. Maybe it's to have a single source of truth. Maybe it's to have process automation. But when you are designing a blockchain use case, you need to be thinking about what's in it for each player. Because if you don't, you can design something that's technically viable, but nobody wants to be on it, and you have a business failure. So again, think long and hard about the incentives that you're going to offer to each participant on the blockchain. So with that, let's get into the workings of a blockchain. It has four broad steps, just to do a quick flyover. Transactions are proposed to the blockchain network, blocks are created, consensus is reached, and blocks are collectively and securely linked. We'll walk through each in turn. So transactions are proposed to the blockchain network. This means everybody's identified with a digital fingerprint. If you're not familiar with asymmetric encryption, PGP, public-private keying, don't worry about it. It just means you can validate who's out there in the network. Now, if it's a public copy of if it's a public blockchain, that identity would be pseudonymous. You don't need to know who's behind the ID. On a permission blockchain, you know exactly who's behind it, but there is encryption on every step of the way. Everybody has their own copy of the blockchain, and transactions are proposed to the network. Say Rick says in a timestamp message, I'm giving Neil $100. Neil says in a timestamp message, Rick's giving me $100. I use my private key, Neil uses his public key, and everybody knows who the parties are that are involved, so it can't be spoofed. And sanity checks are made. Does Rick really have $100 in his ledger to give Neil or not? The second step is that blocks are created, and validating nodes are basically the nodes that say, yeah, we're going to make sure that we all agree on what's happening here. Validating nodes participate to confirm and commit transactions. These could be financial details like the examples we've had. It could also be other transactions. Maybe I put on the blockchain, I'm sending you the lab specimen for John Doe, and that's put on the blockchain, and when you receive it, you put your receipt onto the blockchain as well. So any kind of transaction that you can imagine can be put onto the blockchain. And so the block will contain all the transactions that happened since the last big roll-up or commit activity. The third thing that happens is that consensus is reached. And this is the point where, frankly, the magic happens for blockchain. This is the point where a lot of people are left scratching their head. First of all, let's talk about what we mean by consensus. I would argue that this is a common understanding of meaning and state. If we here at this table are all out for lunch and I say, pass me the salt shaker, you know what I'm looking for. You know that I want that piece of white plastic at the end of the table because we all have consensus on the words. But if I find myself magically transported to rural China, those words have no consensus. We don't have an agreement on what those sounds mean. We think now about the consensus around money. What makes money valuable? I will accept a token as money if I believe it is scarce and if I believe that others in my group will likewise accept it. So think about what we said earlier. Blockchain was the first digital scheme to create scarcity on digital assets. So blockchain solved that problem for scarcity of digital assets. So the first condition for accepting money is made. So now with Bitcoin, all you have to do is believe. If everybody else around you is going to accept this or accept ethers or other tokens, then you have all the elements necessary for cryptocurrency. For a blockchain, again, in this step for consensus, to use digital money, you have to believe three things: that the transaction originator possesses the funds, that after the transaction, the recipient will have the funds, and as an outcome, the originator will not be able to present himself as being in possession of the funds anymore. And there you have all the necessary steps for a cryptocurrency. So Bitcoin consummated this with a very energy-intensive scheme called proof of work. And I have to tell you a personal anecdote, a personal story. It was about 2010. I was still at IBM, and one of my colleagues sent me an email and said, hey, Rick, I know you've read about Bitcoin. What's really interesting is the technology behind it, blockchain. And you should check that out. And I started reading about it, and I thought, well, this looks very interesting, but it's so energy intensive. How could you ever use this? Because, it's ridiculous. And I don't know if you're aware of this today, but most Bitcoin mining, which is the consensus mechanism used with Bitcoin, is done in places like China and Mongolia, where you have cheap and dirty coal, or Iceland, where you have inexpensive geothermal, or Venezuela, where you have subsidized electricity. By most accounts, Bitcoin mining, this consensus step for Bitcoin, uses more power than the nation of Ireland. It is that out of control. But here's the thing. Bitcoin used proof of work for consensus. This is basically the calculation of some very difficult and complex puzzles that have no purpose other than to validate the transactions. But the reason that public blockchain used proof of work is that proof of work removes the need for trust among anonymous actors by reducing the likelihood of an attack by any one malicious actor. Proof of work really aims to prevent any one party from holding a majority of computational resources at one time. Now, here's the good news. If you're implementing blockchain in your corporate and your enterprise and your medical use case, you probably don't need this because you may not trust your competitor with your crown jewels, your intellectual property, but you probably don't worry about them crashing the network and taking it down. So instead, you can use other far more efficient means of arriving at consensus, such as proof of stake, proof of burn, and others as well here. So that's the good news. If you hear about Bitcoin's energy consumption, that is really a novelty related to the trustless system that's out there on Bitcoin. It doesn't apply to you. So the fourth and final step is that blocks are collectively and securely linked. In Bitcoin, this commit process happens about every 10 minutes. Your own blockchain, depending on what you need to happen, it could be more frequently, less frequently, it doesn't really matter. But when this happens, every network participant, again, will have a full copy of the complete data. One question I want to throw out here is really simple. Why is it called blockchain? We've talked about the blocks, but where does the chain come from? Well, there is a mathematical function called a hash function. And I'm an electrical engineer, so these things roll off my tongue, but I told you I'd keep this kind of non-mathematical. A hash function creates, for any varying length data block, a digital signature. So you can have the book War and Peace, or you could have the movie 2001, whatever it is. You can have something, you can run it through a hash function, and it's going to create a fixed length digital signature. And then if you take the last period out of War and Peace, run it through that hash function again, you get a completely different signature. If you cut out the last quarter second of the movie, you get a completely different hash function. So what happens when these blocks are created is that the hash of the previous block is included in this new block. And so if you're creating the 100th block, it's going to have the hash of the 99th, which will have the hash of the 98th, which will have the hash of the 97th. What does that mean for us in plain English? It means in plain English that nobody can go in and change a single bit in any of these earlier blocks. It means that this has, again, an unchangeable, immutable trail. This is why you have a record of all events back to the beginning of time, because these blocks are chained together with the digital signature of the block that came before it. So there you have it, a perfect understanding of how blockchain works. The 4 steps: transactions are proposed, blocks are created, consensus is reached, and finally these blocks are collectively and securely linked. So now you can go teach this yourself. But with that in mind, let's talk about another concept that I mentioned a few minutes ago, and that is smart contracts. In recent years, a huge push has been made to put increasingly sophisticated contracts onto blockchains. These are basically contracts stored on the ledger that can be executed autonomously and automatically. There are 2 closely related concepts. In the upper left up here in the yellow, you see smart contract code and smart legal contract. I think of the former as being what your developer does, write the code to implement a contract, and the latter being what your attorney does. And so these work together to automate basically legal contracts that can be executed without any human involvement. These can contain these contain elements of asset ownership, maybe rights to databases. They also consult external sources of truth referred to as oracles. And don't confuse this oracle with the big database company Oracle. Rather, an oracle is any source of truth that can be consulted to see what's happening in the outside world. Contracts have a defined start and stop date and will take certain actions depending on a series of events. We talked earlier about eliminating the middleman for financial transactions. Now with smart contracts, we can eliminate the middleman in a lot of contractual activity as well. Let me take you through a simple example of this just so you get a good feel for what this looks like. Let's suppose that Mike asked me to ship him some goods, and we're going to codify this in a smart contract. And he says, Rick, I want these goods arriving in my office by a certain date, and I don't want them going through any kind of environmental shocks, not get dropped, no big temperature fluctuations, etc. So we end up saying, what are our oracles? Well, our oracle could be the FedEx delivery man's sign-off sheet that shows when it was delivered. And maybe another oracle could be the accelerometers and the thermometers that are put on the cargo as it's in shipment. And so now we can look at when did the goods arrive at their destination? When did they arrive at your office? Did they arrive on time? Extract no penalty. If they arrived late, extract a penalty according to what's been called out in the contract. Were the goods subject to these environmental fluctuations? Were they dropped? Did they go through temperature fluctuations? Again, if they did, subtract money from the contract. Again, what happens here is we can now execute contracts without any human ever looking at them. Instead of me being paid $100 for my shipment, I'm paid $87.53 based on the terms of the contract. And all this was executed without any human involvement. So now that we all understand how blockchains work and smart contracts work with crystal clarity, let's talk about how we might want to use them. What are the use cases and what are the benefits we're really looking to achieve? Well, to start any use case discussion, I think we need to look at the benefits. And very broadly, they go into different categories like productivity, efficiency, access, quality, cost savings, transparency, better privacy, and of course, speed. So once we have this perspective, we say, okay, great, what are the conditions we should look for to actually say this is a good use case for blockchain? And there are a number of elements that need to fall into place for blockchain to be a good match for you. To decide whether it's a good fit, ask yourself, does this business process have a legal agreement describing data exchange and dispute remediation? Does it have expensive conflict resolution? Does it have multiple parties needing to read and write data? Is there a limited trust between the parties involved? Does it require an intermediary? Does it require audit trails? Does it require physical or virtual ownership tracking? And is there human intervention required to perform data or transaction processes? So the fact is that blockchain is a powerful tool, but with all these conditions laid out, again, you'll see that if a conventional database can do the job, it's often a heck of a lot easier and a lot faster to put into place. It's often a better fit. There aren't many things that really line up behind all of these criteria for a use case. But here's a big surprise for you. There's one environment, there's one ecosystem that really comes to mind that says this seems to fit those conditions. If you think about healthcare, we have these players. We have the legal and regulatory requirements. We have audit trails. We have often significant human involvement to reconcile transactions and disputes, which is one of the reasons why there is so much excitement about using blockchain in healthcare. So let's go a little bit further. We talk about use cases. We need to really begin to devolve our thinking. We've talked about how blockchains work. We've talked about when it's good to use them. We've talked about elements of smart contracts. So how would we begin approaching blockchain use cases for healthcare? Well, I would argue that, at Optum, we view really three broad categories of healthcare blockchain use cases. One is around managing and exchanging data, another is around automating processes, and a third is around tracking and tracing assets. But again, putting on our healthcare hat and start thinking about what this might look like in practical terms, we can devolve these further. So for instance, managing and exchanging data could involve the Internet of Things, basically distributed intelligence in the ambient environment. It could involve provider data. It could involve longitudinal health records. Tracking and tracing assets certainly could include DME, lab specimens, as well as pharmaceuticals. And even so, we can take those down one step further and say within these categories, you can break these apart into other subcategories as well. And this is not a comprehensive list. I'm sure just based on your own experience and what we've talked about today, you can probably see other use cases that I've not delved into here. But I want to put this forward to stimulate your own thinking about blockchain's possibilities in healthcare and ways that we at Optum see it going. So there was a reason that I wanted to put this talk off until April after an original proposal of March, and that was because I wanted to wait until after we had an announcement, which came out earlier this month. Just this month, we, along with Humana, Multiplan, Quest Diagnostics, and United Healthcare, made a joint announcement that we're putting together a new blockchain proof of concept to manage provider data. Industry estimates are that more than $2 billion are spent annually on managing provider data. And so we're looking to see if we can share this data across organizations, and can we, in fact, improve data accuracy, streamline administration, and ultimately improve access to care. So this has just been launched. It's, again, in the early phases, but you may want to keep your eye on this over the course of the coming year or so and listen for results. So earlier I mentioned that there are multiple blockchain platforms available. Saying you're going to put something on, quote, the blockchain is kind of like saying you're going to take the vehicle to Europe. Some vehicles, such as the 787, are well suited to go to Europe. Other vehicles, you know, the 1998 Toyota Corolla are not well suited to take to Europe. And so the fact of the matter is that we need to begin looking at what blockchains might be well suited for our purposes. The list over the next 2 pages is not comprehensive, but again gives you just a picture of some of the common platforms out there for experimentation and application development. Ethereum, founded back in 2014, it's a very popular public blockchain. There's also an Enterprise Ethereum Alliance focused on permissioned commercial uses. There's a lot of smart contract capabilities, and there's a tremendous amount of interest among corporate entities around using Ethereum. Hyperledger, an open source collaborative blockchain brought to you by the Linux Foundation. So the same people that brought you the Linux free operating system are behind Hyperledger. This likewise has a tremendous amount of buy-in and stakeholders in a variety of vertical sectors, including finance and banking, IoT, supply chain, et cetera, et cetera. It has both public and permission networks. Multi-chain is basically a platform for permission blockchains. This is frankly based on the Bitcoin core software, but now it's been revamped for financial transactions. We have Quorum, which is an enterprise-focused version of Ethereum. I mentioned earlier that a lot of permission blockchains have been driven by financial industry. This was actually developed by JP Morgan. Earlier we talked about proof of work, taking all the power of a small country. JP Morgan technology, Quorum, uses vote-based consensus. They simply say, here are the transactions we saw. Everybody raise your hand if you think this is the right one. So it can get very, very simple compared to what we see in these public trustless blockchains. OpenChain is one I don't know a whole lot about, but I included it on this list. It's a distributed ledger for managing digital assets. Interestingly, it's based on a client-server architecture rather than peer-to-peer. Finally, because I worked with IBM for quite some time, I point out that IBM blockchain is out there as well. A lot of corporate customers picking this up. It's built on top of Hyperledger and offers additional enterprise capabilities. The point that I would make is if you think blockchain is a good match for your organization, I would urge you to begin defining use cases, figuring out who the participants would be, what their incentives might be, and ultimately figure out what platform might best serve your interest. If it were me and I were thinking about diving into blockchain, I'd get one or two technical people, put them in a sandbox, tell them what you're trying to do, and have them go out and start experimenting with these platforms to see which one is a good match for your use cases, for your participants, and for your incentives. So I've kind of gone through a whirlwind of information today. I'll repeat this statement that we talked about earlier. Blockchain is most useful when loosely coupled organizations want to confidently share and audit information and automate mutually beneficial processes. We're seeing this in the real world. It's loosely coupled organizations coming together over blockchain. These days, I'll be frank, there's a lot of a tendency for companies to view blockchain as this great new hammer, and every business process you have looks like a nail, and you're trying to use blockchain in ways that maybe it shouldn't be used. I have a friend of mine who shall remain nameless, who is a CTO of a company, and his boss, the CEO, said, we need a blockchain production solution. And his boss didn't care what that production solution was going to be, but he wanted to be on top of the latest technology, wanted my friend, the CTO, to get a blockchain production solution out quickly. I would argue that's the wrong approach. It really is the time for asking yourself, do we have processes that could benefit from the characteristics we've laid out here? I don't have current numbers, but as of last fall, I think it was September, Jerry Cuomo, the vice president of blockchain for IBM, was on record as saying that they had run 400 or so blockchain projects with customers, and only about a dozen had been put into production. So think about that, 400 customer projects, but only a dozen in production. I would argue probably that today it's about that same ratio. Let's widen our aperture in the way that we think about blockchain for just a minute. Let's go back to the early days of the web. We were celebrating these new democratizing technologies. We were all now for the first time back in the early 90s getting email using this great new protocol called SMTP, Simple Mail Transfer Protocol. We were getting information now suddenly. I remember the old Mosaic browser, getting information from faraway places using HTTP and HTML. And all these rested on top of these other protocols like TCP/IP. No one party owned these technologies. And we saw this as a great new opportunity to disseminate information in grassroots fashion. Earlier, I called it democratizing technologies. Fast forward in time, and we see that companies of huge value have figured out really imaginative ways to harness these protocols. If you look at the combined market cap for Facebook, Amazon, and Alphabet, Google's parent, that's almost $2 trillion in market capitalization from people that figured out how to use these protocols in imaginative ways. And they've also used these protocols to collect tremendous amounts of information about you. So those democratizing technologies didn't quite play out exactly the way we would expect. Blockchain is a new democratizing technology. I firmly believe that, but it is also going to be, as well as democratizing, an opportunity for giant companies, again, to be formed. I would also argue that lack of a blockchain strategy today is kind of like having a lack of an HTTP strategy back in 1991. Right now, there are 8 ISO standards around blockchain still being developed. so we see the technology is early in its life cycle. The other thing I would say philosophically is that blockchain really changes a lot of relationships, traditional business models. Instead of creating value by owning something, now you can create value by maintaining the ledger or improving underlying protocols. It also changes the relationship between founders, investors, and customers. So I believe that blockchain is going to play an important role over the coming decade, 2 decades, but really it is very early to say exactly how it's going to shape out. Could you have imagined Facebook Live when you first went on to your Netscape browser back in the early 90s? So, you know, people say, Rick, should I be developing production solutions? I think you've already figured out my position on that. I can't tell you what's right for your business. My belief is that a lot of companies don't need production solutions today, but it is time, if you are a technology company, if you have these kind of business processes, to begin experimentation. Only by a process of experimentation and learning will you understand what's possible, where the risks lie, and how to create ecosystems that will work for you. So with that, I figured there might be interest in this chart. Let me put this picture up once more and open it up for whatever questions you happen to have.
Well, great. Thanks, Rick Hamilton, for a really interesting overview of blockchain technology. So we'll open up the webinar now for questions, either locally or from anyone who's on the webinar on the internet.
Yeah.
Rick, you mentioned this proof of work that consumes the energy of Ireland. Can you just elaborate on what kind of work is done that's considered proof?
Well, I told myself I wasn't going to go into SHA-256 and too many aspects of it. So let me give you an example of proof of work that we can all easily envision. Imagine a spam prevention program that causes your computer to perform, say, a half-second worth of calculation before you send an email. How many emails do you send a day? Maybe 15, 30, 45? You know, somewhere in that. If you force your computer to do a half-second of work, that's not that big of a deal for you every time you send out an email, so no problem. But now, if you want to be a spammer who's going to send out 100,000, a million, 10 million emails a day, if you had this proof of work in place, that prevents that spammer from successfully spamming the network, because you're making them actually work to do something that is, frankly, malicious. Now, let's talk about the fact that we're trying to prevent, with proof of work, any malicious actor from seizing control of the network. We make this concept, likewise, solving these puzzles, solving these mathematical challenges, just sufficiently difficult so that no one actor can actually get control of the network. This was a brilliant way of creating a trustless system where you have people from all over the world who aren't known by their real identity, forcing them to do this kind of activity so that they can't seize control of the network. But when it comes down to a corporate application, to an enterprise, to a healthcare application, it's something that has little relevance for us, if that helps. Good. Yes, other questions?
So we have a question from the web. Do you see any public permissionless blockchain applications in healthcare? Have you seen any interesting startups solving these problems with blockchain?
The short answer is I have not seen public permissionless blockchains in healthcare. I can't talk about some of the details of what we're doing, but I will tell you it is certainly a permission. We feel that having control over participants on the blockchain is very important for anything healthcare related. And the second question, have you seen any interesting startups solving problems? Does that say solving these problems? Healthcare problems with blockchain? Yes, as a matter of fact. I didn't know whether I was going to use this or not, but last night before bed, because I'm this kind of geek, I was reading an IEEE Spectrum, which is the Institute of Electrical and Electronics Engineers magazine, and I came across an article that says, "Get paid for your genetic data. A startup bets on the blockchain to get people to sequence and share their genomes." And again, mind-boggling. Part of the beauty of blockchain is it allows us to maintain control of our own personal information, because you can have your personal information on your blockchain and choose when and where to share it. But this startup called Nebula Genomics basically is using blockchain to reduce the cost of personal genome sequencing, to cut out the middleman and make it easy for individuals to share full genome sequences. Very broadly, it works by having customers to participate in a detailed health survey. Then companies interested in particular traits or diseases pay customers with those characteristics to access their genetic data. They get tokens, customers get tokens, and those tokens can be used to pay for your own genetic sequencing. And so I had no idea this existed until 11 o'clock last night. So are there interesting startups? Absolutely there are. This is just one small tip of the iceberg. There's a lot of companies out there asking, what about these characteristics of blockchain, the digital scarcity, the ability to control the data in your own blockchain? How can we leverage this in new and interesting ways?
What do you see as the greatest stumbling block of implementing blockchain solutions within healthcare?
The greatest stumbling block. I will go back to this question of incentives. And so right now up on the page that we see on the screen, we have the categories of use cases that we had talked about earlier. We talked about, we defined within Optum. And so for any one of these, we have to ask the question, what are the incentives for me to come together with all these different players? You know, we talked about the many different parties in the healthcare ecosystem. Everybody has to have a reason and rationale to come there. If you say, well, one stumbling block is privacy, is security, is access to that, whatever. These are engineering problems. They can easily be solved. The most difficult problem to always solve in a blockchain implementation is that of incentives. What is it that brings each party to the table and makes them feel like, yes, this is a good return and good reason for me to be participating? So it's something we think long and hard about designing when we put a healthcare blockchain in place.
I have a question.
Okay.
There seems to be some inherent scalability challenges with blockchain. We talked about energy consumption, but storage, transaction latency, and those kind of things. How do you see the technology evolving to conquer some of those?
Excellent question. And I would tell you the energy scalability is really only a situation with the public or trustless, permissionless blockchains. Because as I said before, they have proof of work needed because you have anonymous participants. So that's not an issue. However, there are some interesting prospects in place that, let me actually back up a little bit. Think about what we're doing. We're creating a blockchain that has a link of all records throughout time. And that works really well if you think about your blockchain has been running for a few months. But now think about a blockchain that's going to have a multi-year life. And now you begin to ask what records are being put on there. Think about starting to put not just simple textual records, but putting rich data on there as well. And so there are a number of interesting proposals around how we manage this longitudinally. So far, it's kind of like worrying about, to use, I think it was Andrew Ng's words about AI taking over the world. He said it's kind of like worrying about overpopulation on Mars. So yes, one day it may be a problem. It's not a problem yet. But there are, as you point out, some proposals afoot to say, how do we scale this so it's not just something that works for a few years, but works longitudinally. Anyone else? Yes.
So, and this maybe dovetails with that a little bit, but like what sort of practical limitations, you know, as you have maybe a Bitcoin that's been around for 10 years now, and it has, if I'm understanding correctly, it has a complete record of all the people that have touched that Bitcoin over the years.
Right.
Practically, like, you know, what is the size and memory of that Bitcoin after a little while?
I'm going to have to pull up Google on my phone and double check it. I think that the size of the Bitcoin database is surprisingly small. I think it's in the hundreds of gigabytes, but I could be wrong on that, like 130 gigabytes or something around that size. So think about Bitcoin and the way it's evolving over the course of time. I mean, the rate of coins, of tokens being paid out is slowing down over time. The complexity of the calculations will be modified over time. There's some self-regulating mechanisms in place with that. I would urge you to recognize that blockchain will transform over the course of time. I believe the fundamental beauty of this solution is the idea of having this visible ledger that creates this immutable, unchangeable audit trail back over the course of time. And so if we now begin to think of blockchain as a list of open books that processors can go through and understand all the steps that have happened before now, that concept will be transformed, and we'll see other blockchain transformations and other innovations coming in coming years.
Okay. And one other sort of follow-up question to that too is, if I would assume that if you own a Bitcoin or some kind of blockchain currency, that you can't go back and see all the other specific people that have used that Bitcoin over the years and, you know, what they bought and that kind of stuff, correct? You can only see what you've done. Is that correct?
And so I'm not a Bitcoin enthusiast, and I will have to go on the record as saying I think that Bitcoin smells of Dutch tulips. And that said, I was giving a talk. I won't mention what the organization was. I was on a panel, and I was in Charlotte, North Carolina, and I had the panel was nominally about blockchain, and all of the questions coming to the panel were about Bitcoin. And I said, no, look behind the shiny bauble. And so I would defer to some Bitcoin enthusiasts to go back and give you the details on that. For me, what's interesting, though, is this open ledger and the ability to see this history of transactions. Remember, in Bitcoin, everything is pseudonymous. You don't know who's behind this. When it becomes really powerful is now if we as a corporation and you as another corporation can come together and look at our history of transactions. You also have interesting governmental activity going on. Right now, the city of Dubai is making big bets around blockchain, trying to put a great number of services into the blockchain so that you have this new level of transparency previously unmet in government, particularly in government of that part of the world. So again, focus on the underlying technology and what becomes possible when we have this unchanging open ledger. Okay.
Do you see the investment healthcare industries have placed on the EMR could create issues around accepting a new one centralized technology? And in your opinion, how would one bridge this when discussing with those significantly invested in EMR?
Excellent question. And so we're all aware of, say, work around FHIR standards and other big picture efforts to standardize health records. I believe that any blockchain solution would ultimately have to be compatible with these other standards put in place. The challenge, of course, will be getting, I would say, all the parties, both private sector and governmental bodies, to come together and say, yes, this is the right thing to do. But I think compatibility is going to have to be there, because otherwise you're making the investment in these standards, the technology around these standards, and you're not going to throw that out. There's ways that these can both play together in the same sandbox.
How can you enforce immutability and true censorship-free environment while using private blockchain?
Well, regarding immutability, remember that we've got the hash of the previous block, the digital signature of the previous block contained in each. And so if you were creating, say, the second block in a blockchain, it contains this digital signature pointing back to the first. If anybody tries to go and change a piece of that first block, several things happen, right? One, you have a lack of synchronization across the network, which is immediately be detected. But secondly, that hash can immediately be checked, and you can find out that that first block has been changed. So immutability is taken care of by the hash. What is the second part of that question? Censorship, true censorship-free environment. I would argue, and I'm going to go back a few slides here. I would argue that censorship was a big concern for the original, I would call them digital libertarians who were worried about Bitcoin and the trustless networks. But I would tell you that in the complex environment that healthcare sits in, we all have needs to certain pieces of the data, but we don't have needs. We don't all need all the data. And so that's the beauty of a permissioned network, is that you can define for each of these players who has access to what data. And so if we talk about censorship, well, maybe that's censorship, but again, this is driven both by regulatory and by common decency reasons that we don't want everybody to have free and open access.
Are blockchains complete overkill for use cases completely inside a single institution? If not, what consensus model would be most efficient?
Are blockchains overkill for business processes within a single institution? I would say it depends. There's no one right answer for that. But go back to these use case descriptions we talked about before. Do you have within your organization the need for dispute remediation? Do you have conflict resolution? I think within a single organization, you almost certainly have multiple parties reading and writing. You know, is there really limited trust between transacting parties? For most single companies, you know, it may be overkill, but I'm not going to tell you that with a blanket statement. If your internal politics and internal workings of your organization meets these criteria, then there may be use cases that could be constructed within a single organization. I would also tell you that organizations have different degrees to which they are coordinated. So it's hard to answer without knowing the specifics of the organization. What consensus model would be most efficient? Well, one thing's for certain, you're not going to need proof of work, because we realize we only need proof of work that's energy inefficient mechanism if you have a totally trustless system. There's a lot of advantages and disadvantages to each of the other kinds of consensus mechanisms. As I mentioned before, Quorum has a simple vote-based system. If we all agree these are the set of transactions that occurred, everybody nods their head yes, then that is not very inefficient at all. It's very, very, very efficient, easily conducted. But again, you could look at others like proof of stake, proof of burn, figure out what's really right for you. Other questions? Other thoughts?
Other questions? Well, this concludes today's webinar. It will be available on our website for viewing within the next few days. Thank you again, Rick Hamilton, and thanks for all of you for joining us today. Stay tuned to our newsletter and website for invitations to future webinars.